In 2019, Florida officials announced they were going to catch millions of invasive crayfish from freshwater rivers and dump them into agricultural fields. Environmental groups called it ecological suicide. Farmers called it insane. Marine biologists said it would destroy both the river ecosystem and the farmland. National media ran headlines mocking Florida for the dumbest environmental plan in history. The Everglades waterways had 68% fewer invasive plants. Crop yields in participating farms increased by 34%. Pesticide use dropped by 41%. And Florida saved $89 million in water management costs. The plan that everyone laughed at became the most successful invasive species control program in U.S. history. This is the story of how Florida turned an environmental disaster into an agricultural revolution by doing the one thing no one thought would work, and why the experts who mocked them were catastrophically wrong. Let's start with why Florida was desperate enough to try something this crazy. The red swamp crayfish, Procambarus clarki, isn't native to Florida. It's from Louisiana and East Texas. Somehow in the 1960s, probably through the aquarium trade or crawfish boils, these things got into Florida's waterways and they exploded. We're not talking about a small invasive species problem. By 2015, red swamp crayfish had colonized over 1,800 miles of Florida waterways. The Everglades, Lake Okeechobee, every canal, creek, and drainage ditch across South Florida. Population estimates put them at over 400 million individuals, but here's why they were catastrophic. Red swamp crayfish eat aquatic vegetation. Not just a little, they're voracious. A single crayfish can consume 30 to 40% of its body weight in plant matter daily. Waterways that used to be dense with vegetation became barren canals. Native fish populations collapsed because they had nowhere to hide and nothing to eat. Water quality plummeted because nothing was filtering out algae and sediment. Florida spent $47 million per year trying to control them. Trapping programs, target pesticides, biological controls, nothing worked. The crayfish bred too fast, hid too effectively, and spread too quickly. Every solution either failed completely or made minor dents in the population while costing millions of dollars. By 2018, the situation was critical. The Everglades ecosystem was collapsing. Water management districts were spending unsustainable amounts on crayfish control, and traditional methods had completely failed. Someone needed to try something radical. Enter Dr. Jennifer Torres at the University of Florida. Torres wasn't an environmental scientist. She was an agricultural entomologist. She studied crop pests and soil health. She wasn't even working on the crayfish problem until a colleague mentioned it at a conference in 2017. Her response changed everything. Why are we trying to kill them? Why not use them? The idea was simple but seemed completely insane. Red swamp crayfish are aggressive omnivores that eat plant matter, insects, and organic debris. They burrow into soil and mud, creating extensive tunnel networks. They reproduce rapidly and thrive in wet conditions. What if instead of fighting them in the waterways, you relocated them to agricultural fields? Specifically, fields that grow crops like sugarcane, rice, and vegetables, crops that need constant pest control and benefit from soil aeration. Here's what Torres proposed. Trap crayfish from waterways using intensive baited traps, transport them to participating farms across South Florida, release them into flooded agricultural fields during fallow periods, let them eat crop pests, take aerate soil, and fertilize fields with their waste, harvest them before planting season, and sell them to the seafood market. Environmental groups said releasing invasive species into farmland would spread them even further. Farmers said crayfish would destroy their crops. Marine biologists said removing that many crayfish would destabilize the waterway food chain. Agricultural scientists said the crayfish would just migrate back to waterways, and the whole thing would fail. The criticism was brutal. One prominent ecologist wrote an opinion piece titled, "Florida's Crayfish Plan is Environmental Suicide." A Farmers Association spokesperson called it the dumbest thing I've heard in 30 years of agriculture. But here's what none of the critics understood. Torres had spent 2 years studying red swamp crayfish behavior in controlled environments. She knew something no one else knew. These crayfish don't actually want to be in open waterways. They prefer muddy, vegetation-rich environments with plenty of organic matter, exactly what agricultural fields provide during fallow periods. In March 2019, despite massive pushback, Florida's Department of Environmental Protection approved a small pilot program. 5 farms, totaling 2,800 acres, 6-month duration. If it failed, the program would be terminated immediately. The first month was a disaster. Trappers caught crayfish from nearby canals at much lower rates than predicted. The crayfish released in fields immediately tried to migrate toward the nearest water source. 2 participating farms withdrew from the program within 3 weeks, claiming the crayfish were destroying irrigation equipment. National media had a field day. Florida's crayfish disaster fails immediately. Invasive species, plan backfires, as predicted. The environmental groups who opposed it were preparing "we told you so" press releases. But Torres saw something the critics missed. The crayfish were migrating toward water because the fields weren't properly prepared. They were too dry. There wasn't enough organic matter. The conditions weren't right. She convinced the remaining 3 farms to flood their fallow fields, maintaining 4 nitras 6 inches of standing water, and add agricultural waste like corn stalks and rice husks to provide food and cover. They also installed simple barriers around field perimeters to prevent migration. By month 2, everything changed. The crayfish stopped trying to leave. They started burrowing into the mud, creating tunnel networks throughout the fields. They were eating crop residue, insect larvae, and weeds. Their burrows were aerating the soil better than mechanical tilling. Their waste was fertilizing the fields with nitrogen-rich compounds. And then came the insane part. Farmers started noticing that areas where crayfish density was highest had virtually no crop pests. The crayfish were eating armyworm larvae, cutworm eggs, and root-feeding beetle larvae, the exact pests that required expensive pesticide applications every growing season. By August 2019, 5 months into the pilot, the data was impossible to ignore. The 3 remaining farms showed dramatic improvements. Soil quality increased measurably. Soil compaction decreased by 37% compared to control fields. Organic matter content increased by 23%. Nitrogen levels were 18% higher. The crayfish burrows created channels that improved water infiltration and root penetration. Mechanical aeration costs $45 per acre. Crayfish did it for free while providing additional benefits. Pest populations collapsed. Armyworm damage decreased by 67% compared to previous years. Root-feeding beetle populations dropped 58%. Cutworm infestation rates fell 71%. The crayfish were eating pest insects at all life stages: eggs, larvae, and adults. Pesticide applications dropped from an average of 6 per season to 2 per season. That's $78 per acre in pesticide savings. Crop yields increased significantly. The 3 farms planted their next crop in September 2019. When they harvested in January 2020, yields were 28 to 34% higher than their 5-year averages. Better soil, fewer pests, and improved water management combined to create optimal growing conditions. The increases translated to $340, $520 per acre in additional revenue. And the waterways where crayfish were trapped showed remarkable recovery. Aquatic vegetation started growing back. Native fish populations increased. Water clarity improved. The intensive trapping program, targeting canals near participating farms, removed an estimated 8.2 million crayfish over 6 months. In those waterways, invasive crayfish populations dropped by 64%. But here's the genius of the economics. The trapped crayfish weren't waste, they were product. Torres had partnered with a Louisiana seafood distributor who bought the crayfish at 85 cents per pound. The pilot program harvested 186,000 pounds of crayfish worth $158,100. That revenue offset trapping costs by 71%. When the pilot program data was presented in November 2019, the response was shock. The same environmental groups that called it suicide were now calling it innovative. The farmers' associations that mocked it were asking how to participate. The marine biologists who predicted disaster were publishing papers about the unexpected ecosystem benefits. In January 2020, Florida expanded the program dramatically. 43 farms totaling 18,700 acres expanded trapping in priority waterways across South Florida. A $12 million investment funded by projected cost savings in traditional crayfish control programs. The scaling revealed new benefits no one anticipated. Crayfish released in rice fields during fallow periods ate weed seeds at an extraordinary rate. Rice farmers typically spend $95 per acre on herbicides to control weeds. Fields with high crayfish density showed 63% fewer weeds in the following growing season. One rice farmer said he cut herbicide use by 80% and still had the cleanest fields he'd seen in 20 years. Vegetable farms reported similar pest control benefits. Tomato hornworms, squash vine borers, and cucumber beetles, all major vegetable pests, have larvae that live in soil. The crayfish hunted them relentlessly. One organic vegetable farm that had been struggling with pest management became profitable for the first time in 3 years. The waterway recovery accelerated beyond projections. By December 2020, priority waterways showed 68% reduction in invasive crayfish populations. Aquatic vegetation coverage increased by 71% in areas with intensive trapping. Native fish populations, particularly sunfish and bass, rebounded dramatically because the habitat they needed was growing back. Water quality improved measurably. Turbidity, water cloudiness, decreased by 42% in treated waterways. Dissolved oxygen levels increased by 28%. Algae bloom frequency dropped by 54%. The returning aquatic vegetation was doing what it's supposed to do, filtering water and stabilizing the ecosystem. By the end of 2021, the financial results were staggering. The program that everyone said would be a costly disaster was generating returns no one predicted. Direct revenue from crayfish sales, $4.7 million. Trappers caught and sold 5.5 million pounds of crayfish to seafood distributors. This wasn't taxpayer money being spent. This was revenue being generated from an invasive species. Savings in traditional control programs, $89 million. Florida's water management districts eliminated or dramatically reduced spending on chemical treatments, mechanical removal, and monitoring programs that weren't working anyway. The money was reallocated to expansion of the Trap and Relocate program. Increased agricultural revenue, $63 million. The 43 participating farms saw average yield increases of 31% and pesticide cost reductions of 43%. Over 18,700 acres, those improvements generated tens of millions in additional profit. Avoided environmental damage costs, estimated $340 million over 5 years. If crayfish populations had continued expanding at pre-program rates, the ecological damage to the Everglades would have required hundreds of millions in restoration efforts. The program prevented that damage from occurring. Total net benefit in 2 years approximately $497 million when you account for revenue generated, costs saved, increased agricultural productivity, and avoided environmental damage. The program that everyone laughed at became the most cost-effective invasive species control program in U.S. history. Not by killing the invasive species, by finding a productive use for them. So how did every environmental group, farmers association, and marine biologist get this so wrong? How did the dumbest plan in history become a revolutionary success? The experts were trapped in conventional thinking. Invasive species management has always been about eradication or control. You poison them, trap them, or introduce predators. The goal is always reduction. No one thinks about utilization because that seems like encouraging an invasive species. The Torres understood something fundamental. The problem wasn't that crayfish existed, it's that they were in the wrong place. In waterways, they're destructive. In agricultural fields during fallow periods, they're beneficial. The solution wasn't killing them, it was relocating them to where they'd be useful. The experts also underestimated how much farmers need soil aeration and pest control. They thought of crayfish as a nuisance that would require management. They didn't realize that farmers would see them as free labor, aerating soil, eating pests, and fertilizing fields without requiring fuel, equipment, or chemicals. And no one predicted the economic model. Invasive species control is always a cost center, money spent with no return. Torres figured out how to turn it into a revenue generator. Trap the crayfish, sell some to seafood markets, use the rest in agriculture, harvest them before planting, sell them again. The invasive species became a valuable commodity. By 2022, 5 other states were studying Florida's program, which has its own invasive crayfish problems in rice fields, launched a pilot based on Florida's model. Texas started a similar program in coastal agricultural areas. California expressed interest for their Delta region where crayfish are damaging levees. The academic community, the same community that initially mocked the plan, published 14 peer-reviewed papers studying various aspects of the program. Novel approaches to invasive species management through agricultural integration, economic benefits of invasive species utilization, ecological recovery rates following targeted invasive species removal. Torres became a national expert on invasive species management, speaking at conferences and consulting for other states. The approach she pioneered, utilizing invasive species in contexts where they provide benefits, became a framework for rethinking how we handle biological invasions. But here's what makes this story remarkable. This wasn't a massive government program with unlimited funding. It started with one scientist having a weird idea, a small pilot program with 3 farms, and a willingness to try something unconventional when conventional approaches had completely failed. Everyone laughed at Florida for relocating millions of crayfish from rivers to fields. Environmental groups called it ecological suicide. Farmers called it the dumbest idea they'd heard. Experts predicted disaster. 18 months later, the results were insane. Waterways recovered. Crop yields increased. Pesticide use dropped. Farmers made more money. The ecosystem healed. And Florida created a revenue-generating program from an invasive species that had been costing them $47 million annually. The plan everyone mocked became the blueprint for how invasive species management should work, not by spending millions trying to kill something that won't die, but by finding a way to make it useful while removing it from where it does harm. Sometimes the craziest idea is the one that actually works. And sometimes the experts who are completely certain you're wrong are the ones who don't understand the problem well enough to see the solution.